Hey guys, welcome back to the channel. So today we're going to do the second part in our Tuning Foxbody Mustangs for Boost series. The first part that we covered was really just around how to set up fueling for boosted applications. And this is kind of in a simulated Foxbody 5-speed mass air car with a Vortec blower, just kind of a common combo that a lot of you guys might actually have. And so we covered a lot of the basics for fuel in that video. In this video, we're going to talk about the fundamentals of spark control. And this video, we're not really going to get into changing a whole lot in the tune. This is more about helping you guys understand how these computers are controlling your timing, because there's some different opinions on how you should do this stuff, not even just with boosted cars, but really with any of them, with these Fox bodies. So I'm going to use this as an opportunity first to teach you guys how these strategies work. And then in the third part, which we'll get into next, that's when we're actually going to change all the settings we need to set up your spark tables. Now, the very first thing I want to talk about is the fact that your computer always assumes that you've set your base timing on your distributor at 10 degrees before top dead center with the spout connector disconnected. And this might be basic for some of you, but I'm going to go through it for guys that are a little bit newer to these cars. So when you're going to set your timing, before you get into all this computer stuff, you need to get out in front of your distributor and set the timing to 10 degrees. Now, I've gone on to Google and pulled up a few images so we can talk about this. So the process for setting your timing, the first thing you want to do is before you even turn the car on, you need to get out in front of the engine on the distributor. And this little black plug right here is called a spout connector. You need to basically pull this little guy out here. There's a jumper. This is just a simple 2-pin system, and you can remove the tip of this and pull it out and make sure you don't lose it. Fortunately, these days you can buy these now on like LMR and I think a few other places. For years, you couldn't get these, and you'd have to go to a junkyard or eBay, stuff like that. But the first thing you need to do is pull this guy out. And a little close-up look of what that is, it looks like this little gray piece right here. The car will start just fine, or at least it should, and then you can set your timing accordingly. So you pull the spout plug out. You want to do this before you start the car. Now, you can't see it in this picture, but down here at the bottom of the distributor where it goes into the block, there's just going to be a little 1/2-inch bolt. You want to take that loose. You'll probably use just a ratchet with an extension and a swivel, and just break it just loose enough so you can physically twist the distributor left and right to set the timing. As you turn it right, it advances the timing. As you turn it left, it'll lower the timing. And then ultimately what you're going to do is you need to buy a timing light, which is going to have you hook up to the battery, positive and negative. And then there's a little clip that goes over your spark plug wire for your number 1 cylinder. And the number 1 cylinder is on the passenger side of the engine. It's going to be the cylinder farthest forward or closest to you when you're leaned over the engine bay. So you'll clip that wire on, you'll set up the positive and negative, and then you'll essentially point the gun down just to the passenger side of center down by your water pump, and you're going to see something like this. So this is actually your balancer at the bottom of the motor. And when you look at this, you'll see a mark right at 0. These things should always be marked. Your balancer might look a little bit different, but this is kind of what a stock one would look like. So you have a mark right here at 0. When we go to the left of this mark, this is after top dead center. This is not where we want to be at all when we're setting timing. We're definitely going to be out to the right of this. And then to the right, you'll have basically every one of these hash marks, again, at least on this particular balancer, represents a 2-degree change. So 2 degrees before top dead center, 4, 6, 8, and then 10, and they have kind of a longer mark here. You keep going 20, 30, and some of these are marked pretty far around. Some of them stop at around 30 or 40. And what you're going to need to do is get some kind of a white paint or bright yellow, something that's really easy to see against the darkness of the balancer itself. And you need to make a mark at exactly 10 degrees on here, because that's ultimately what you're shooting for. And so as your timing light's flickering and you point it down there and you're looking at it, you're going to see this little pointer, and you can actually see the flat edge of your timing pointer here in this picture. But in another one, you can see the entire mechanism here. And this is a little bit easier. So you're looking at basically where that white line that you just put at 10 degrees before top dead center, when your light flickers, it should look like it's exactly in alignment with this flat edge. And you're going to twist your distributor until it's right there, hold it, lock down that 1/2-inch bolt, and then double check it after you've tightened that bolt down, just to make sure that you didn't accidentally twist it a little bit. It's very sensitive, and when you're dealing with the boosted application, this stuff's really important. You really need to make sure this is accurate, Because if you try to take some guy's advice on the internet, including myself, you start deciding, okay, I'm running this much boost, let's run this certain amount of timing, and the tune and everything should be happy and I won't blow it up. Well, if you did this wrong to begin with, then you can still cause a lot of damage. I mean, you can blow holes in pistons and everything else. The other thing I want to say here is if you're still running a stock balancer, you might also want to make sure that that balancer is in good shape, because those balancers were a two-piece design, and you can actually kind of see this in this picture. There's an inner ring and an outer ring. And as that stuff wears out and that rubber degrades, which, I mean, if you're still running the stock one 30 years later, there's a really good chance this thing's shot. I replaced one on one of my cars recently. And what'll happen is the outer ring twists from where it truly is supposed to be. So what happens is, even though you think you're setting it where the mark shows, well, that outer ring has spun. They call that, your balancer's being spun. So whatever you're setting it to doesn't matter anyways, and you're not getting an accurate reading. So what you should be able to do, if everything's mechanically sound, you should be able to set your timing to 10 degrees with that spout disconnected, get it locked down, double check it, turn the car off, and then plug the spout back in. And the reason you have to unplug that little spout connector to do this is because that's basically what allows the computer to control your timing. If that's plugged in, the computer's making adjustments. If you unplug it, the computer's unable to complete its signal and it can't set anything. So it'll stay exactly where you set it. When the computer's controlling things at idle, it doesn't stay at any one place. It actually is what's called closed loop idle, and it swings back and forth. In a stock car, usually somewhere around 15 degrees all the way up to probably close to 30 degrees. And it usually centers out somewhere around 22 degrees unless you mess with the tune. So, that thing's going to be a moving target if you leave that spout connector plugged in. So you need to make sure that you pull that out first before you do anything like that. So that's kind of the basics of setting timing. I know we took a little bit to talk about it, but it's really important. And you always want to set it at 10 because you have total freedom in the tune to do whatever you want in all the different conditions. But all of these numbers we're looking at in the tune assume that this is at 10 degrees. And if it's not 10 degrees, then everything's not really what you think it's going to be. Okay, so step one is always get your stuff set to 10 degrees with the spout out, plug it back in. Now we can talk about the tune. Now, going back to my little cheat sheet here. So we've talked about setting up the timing on the distributor. Now, the next thing we're going to talk about is how does the spark strategy work? And again, we're looking at an A9L stock setup right now that we're continuing to modify. I haven't touched any of the timing stuff yet. And there's 4 tables really that are kind of the basis for your timing when the car is moving. You have a base table, a Sealevel table, altitude, and a wide open throttle. And then idle isn't really just one table. There's actually quite a few, and I'm not going to focus on that today. We're going to do a whole video on idle later on, so we're not going to put too much emphasis, but just know that all of these tables, this is really after the car is moving and you start driving. We're working with these. Idle's kind of a whole separate topic. And in addition to these tables, which we'll discuss in a second, you have these various spark adders and subtractors, and this is where there's a lot of safety checks or things when the engine's really cold. It might add a little bit of extra timing. If you're overheating, there's some different places based on coolant and air temp where it's going to subtract timing just to try to protect the engine from detonation. So we'll talk a little bit about these. Now, the first thing that you really want to make sure you do in boosted applications is you want to kill this table right here. And you're going to see why that is. Let me show you how little control you have in this wide open throttle. So basically, the idea is this. As soon as you're sitting at idle and as soon as you step on the gas pedal and you start moving, the first place you're working from is this base spark table. And you can see that this entire timing table is based on figuring out what load you're at versus what RPMs you're at. So this is kind of what you're starting from. And then as soon as you've reached a certain amount of load that is defined by this table right here. So basically when you exceed this load at a given RPM, then you've left the base table and you're going to a combination of Sealevel and altitude. And the reason you have Sealevel and altitude tables is because, Ford ships these cars all over the place. So there's going to be places that are at or below sea level. There's going to be some people that are driving these things up in the mountains. And, the air is totally different. And the amount of timing you can safely run is very different depending on altitude of where your car's driving. So the first thing I'm going to say here is that, there's less timing in the altitude table generally than you'll find at the Sealevel table. and you're gonna get out of the base table very quickly under normal driving anyways. So one of the things most guys will do is they'll go in here and they're gonna tweak some settings that essentially turn off the altitude table and turn off the base table and allow you to make all of your decisions from a single table, and it's a lot easier to do. Other guys, they don't know how to do that, or they don't do it, so they'll get their timing table set up the way they want it with all these numbers, and they'll just copy all of these numbers across all three tables. So regardless of what the motor's doing at a given time and which one of the tables it's actually operating within, you get the timing that you think you're going to get. Now, all of this table, again, this isn't used during idle, and this table by default is also not used during wide open throttle. So the computer understands, based on your throttle position sensor, that when you exceed a certain voltage on that sensor, so essentially when you push the pedal down to a certain point or past it, the car knows you're in wide open throttle, and it completely ignores all of these tables, and it goes to a very, very simple table that's only based on RPM. And the thing is, I've seen some of the mail order guys actually, even on boosted applications, continue to use this table. And I don't encourage it because you don't really have any control based on load. Now, on a supercharged application, you might be able to get away with this. I still don't recommend it, but the reason you might be able to get away with it is because supercharged applications, at least on these cars with just normal centrifugal superchargers, has a very linear boost curve. So as your RPMs climb, you're pushing more boost. As your RPMs go down, the boost goes back away. So, and you don't really have this concept generally of over boosting. Like when you're running a turbo car, kind of a different animal. Turbo cars, you're relying heavily on the wastegate spring, possibly a boost controller that might be mechanical or some kind of electronic component. You've got a lot of factors in there that when you got a new combo, you could have boost creep. One of those components fails or doesn't do exactly what you assumed it would. And maybe you only plan to target 7 or 8 pounds of boost and something goes haywire. Next thing you know, you're running 20 pounds of boost. So you can't safely with the turbo car just assume that you think you know about how much boost you're going to have at different RPMs and set the timing accordingly. Really not safe. The other thing about turbos that makes it a lot different than a supercharged car is turbos and that boost level you achieve really is very much load driven. If you're sitting in a turbo car without some kind of an anti-lag box or, a two-step or something like that, and you're just free revving in neutral, you can jam that thing all the way to the floor and bounce off the rev limiter if you want, but you're really not ever going to build any boost because there's no load on the motor. You're not having it physically move the car or do any substantial amount of work. So, you have to put load on a turbo to really get that thing to spool up. And when you're in numerically the lower gears, like first and second gear, and you're at wide open throttle with a car, you're going to blow through those gears pretty quick. They're very short gear, and you're never putting quite as much load on the motor. Even if you have full traction, which a lot of you guys aren't going to have anyways in first gear, but even if you did, you're on slicks, you got absolute traction, you're still not putting a whole lot of load on the motor. Your gearing blows right through it. You move on. So as you climb into the higher, numerically higher gears, into third gear, into fourth gear, the same type of RPM at wide open throttle has generally a lot more load on the engine in those gears, or maybe not necessarily a lot more, but it has more load in those gears than it does in first and second gear. So again, if you're trying to make these types of timing decisions at wide open throttle with the turbo car only based on RPM, that's not the same in every gear. So this is really not a good way to do things. You really want to control your timing based on load and RPM, which you don't have the ability to do with this table. And like I said, supercharged cars, you can get lazy if you really want to, but guys, just there's a better way. That's why I'm teaching you guys how to do this stuff. So the very first thing I'm going to show you is how do we turn this table off so this is completely ignored and we have to work from these other three. Very simple thing. You just go to this guy right here under your Spark folder. You scroll all the way down to the bottom, and it's the very last thing here, wide open throttle mode spark control. If this is set to on, this is getting used at wide open throttle. If you set this to disabled, you actually saw a refresh. That table doesn't even show up here anymore. So that's completely ignored. That's not in play. And one last thing I want to show you, just so you understand what's happening. I mentioned earlier that how do you know when you're in wide open throttle technically? I mean, obviously if you're all the way to the floor, you're there, but you technically don't have to be all the way to the floor to get there. And that's controlled with your throttle position sensor. That's what TPS stands for. And when we go here, you'll notice that this guy right here, your break point voltage for wide open throttle. This is basically saying that on that throttle position sensor that knows how far the throttle blade's open, when you get to 2.77 volts or higher, you've transitioned into wide open throttle. And then when you start to let off the pedal and you go back below that, you know, there you go. And this is like all the other sensors. This is a 5-volt sensor. So, well, I say all of them. Mass air is not a 5-volt, but the other ones, the coolant temp, the air temp, the TPS, these are 5-volt sensors. So, you know, this is about 60% of the way to the floor is where you get that. You can adjust this if you want. There's some scenarios where you might want to do that. But, you know, this is where that's actually controlled so you can understand what you're getting at. Okay, so we've turned that off very simply just by going into the scalar function, going down to the bottom, disabling this guy. That table's gone. Now, the second table that we can very easily get rid of if we want to do this, we control right here. So by default, after we get off that base table, so we're kind of leaving off idle, we've very quickly transitioned out of the base table, and now we're either in the Sealevel table or the altitude table or somewhere that's a blend between the two. And it's kind of interpolating between those. And the way it does that is by understanding the barometric pressure of the atmosphere where you are. So again, you know, if you're driving around and you're going through a big mountain cruise or something, you're going way up in elevation, coming back down and changing constantly, that barometric pressure sensor that's attached to your firewall over by the brake booster and all that stuff toward the driver's side of the car behind the intake, that guy is exposed to open air. That's ultimately what's helping the computer understand what the pressure is. It infers from that sensor, you know, what kind of altitude you're at, what kind of air conditions you have, and then it's sort of bouncing somewhere between altitude and sea level tables. And again, I want to show this again. Some of you guys are really new to these cars. So I grabbed another picture of this. So when you look in your engine bay, right behind the motor on the firewall, there's this little L-shaped bracket, and there's this big black plastic sensor thing hooked up to it. That is your barometric air pressure sensor. Now, if you have an earlier Foxbody EFI car that's a speed density car, you're still going to have this same looking thing right here. But the difference is that thing, if you look at the bottom port right here, this will actually have a vacuum hose on it and it'll be hooked into your manifold. So we would actually call that a manifold pressure sensor rather than a barometric pressure sensor. But the sensor is essentially the same. So that's even something that part of the process you go through. If you take an old speed density car and convert it to mass air, really the two main things you have to change are you have to wire in the mass air and do some pin changes on the harness. And you also have to disconnect the vacuum hose and just let this guy go out to open air. So just that's kind of a quick heads up on that. But that's where it's located. That's what it looks like. So now you know there's your barometric pressure sensor, and that's why you need it here to interpolate between those tables. Now, we aren't going to really use those two tables. If we're trying to really simplify things, we can go in here and tell it to run off the Sealevel table only. Now, I just want to say this loud and clear, guys. Again, when you're in higher altitudes, the air quality's not as good. You can't run as much timing. There's a reason Ford by default has two different tables that it's switching between. Most of us these days that still have Foxes don't really do a lot of long road trips with them. So yeah, some of us live at higher altitudes than others, but we're not doing a lot of road trips, probably don't see a lot of elevation change. If you're one of those people that it's just a little weekend cruiser, you take it out to the shows or the meetups or the drag strip or whatever you're doing, it's probably okay that you can run off one table and not stress about this at all. But if you actually are still out there putting tons of miles on this thing and changing elevations a lot, just consider what you're doing here by running this off one table. Just, I'll throw that out there. Okay, so for what we're gonna do, we're gonna say Sealevel only, and when we change that, we should see this altitude table over here disappear. And refresh that, you can see altitude's gone. So now we've gotten rid of altitude, and we've gotten rid of wide open throttle, and we're down to the base table and the Sealevel table. So again, now what's gonna happen is as soon as you tip into the throttle, and you're probably at these really low RPMs, and you're probably at the really low load, so you're probably somewhere down in here. This is kind of where you're starting your timing, but as soon as you start to climb up in RPMs and load, it's gonna now transition over to the Sealevel table. If you wanna make this even simpler, there's a way you can turn off the base table and we can run only on the Sealevel table. And this is really at this point what I would recommend doing. If you're gonna simplify it, we'll simplify it all the way. Now lots and lots of cars are out there tuned this way. They run just fine. So the way that you get rid of this is you go into this table right here and you set every number in the load column to 0. Because again, you're starting at base always, and what it's saying is that once you exceed whatever load you put here, it'll transition to the other table. So think about it. If you set all of these to 0, you're always above 0 load at all times. Even when you're just sitting at idle, you're probably at around 20 to 30 load, depending on the combo, maybe give or take a few, but you're always going to be above 0. So by saying that you're always above 0 here, what you're saying is you're never going to be in this table. You're always going to be running off sea level. And you can further handle this situation so you don't confuse yourself, because technically you can't really turn this table off. There's not just a switch you can flip to make it disappear. So it's still going to show up in here. It just never gets used. But the other thing you can do is you can just zero all of this stuff out. And if you've managed to do something wrong here where this table is actually still getting used, your car's going to run like crap. It actually probably won't run at all because you'll step on the gas, you'll have no timing, it'll choke out, and it'll be very obvious to you that something's wrong. If you've set this up correctly, you've got all of these load values zeroed out for this lugging table, then this is all ignored anyways. And now we've really simplified things down to just running off this one table. So that's really the process you go through to simplify things for a boosted application to now run off one table. Now the challenge becomes, okay, now how do we set this up? And there's going to be some things we'll do in the next video. Like you notice this table only goes up to 4,000 RPMs. We don't have any additional control at 5 or 6 or 7 or however high you plan to wind it up. So that's a big problem. And of course, we talked about load in the last video. I mean, even a naturally aspirated car is probably getting up into the 80 to 100 load depending on the setup. You boost it, it might go well up in towards 150 to 200. We have absolutely no timing control unless we modify the scaling on this table. So we're going to do that in the next video, but it's more involved because when you change the parameters in the tune that change this actually affects a lot of other tables too that some of them aren't even related to timing at all. So there's quite a few other places we got to go tweak some things. It's going to be kind of a long video, so that'll be in the next one. But that's kind of where we're at here. Now, one last thing we're going to do in this video before I cut this one off is we're going to talk about adders and subtractors. So the idea now is that anytime we're driving the car, we're somewhere in this table based on load and RPM, but there's also some conditional things that are going on here in these adders and multipliers and subtractors. So the first thing we're going to look at is adders. So right here, this is something that's saying, based on the air temperature sensor being at certain degrees, we're going to pull some timing. And essentially this is saying that once you get up above 160 and you're transitioning towards 190, that's when the timing starts to get pulled. And something you need to know about this is, if this is at 0 and this one's at -2, the timing actually starts getting pulled as soon as you exceed 160, because it's called interpolation, but you could think about it on a plot like this where it's drawing straight lines between the values. So it split the difference here at 175 degrees, it's pulling 1 degree of timing. At 190, it's pulling 2 degrees. And then at this point, anything above 190, it's pulling timing. So this is actually fine to leave here. If you want to get more conservative, you can pull even more timing if you want, but you really need to kind of log and understand what temperatures your car is going to run at when you're really beating on it, kind of how it behaves in the summer months versus the winter months or whatever months you drive it in and where you live. I'll leave this here for now. There's no right or wrong, but one thing I wouldn't suggest you do here in the sake of trying to get, quote unquote, the optimum tune or the optimum performance and get every last little bit out of it. Don't go in here and start zeroing this stuff out and say, yeah, screw safety, we'll be fine. I trust myself. This stuff's in here for a reason. Now, how aggressive you want to get with it is up to you, but you definitely don't want to overheat and keep running full timing and boost the crap out of it. You're gonna have issues. So this is the first adder that it can add or subtract timing. This one's pretty important. The second one here is something that's making timing changes based on coolant temperature. So here, again, you see you've got from 60 degrees coolant all the way up to 230. And you can see up here, this is pulling some timing. And if you're starting to overheat, a lot of these Foxes in the summer months and the southern climate, they're going to run in the 200s. I don't really care what fan and thermostat setup you have. If you're really stuck in a lot of traffic or you have a lot of extended idling, most of those cars are going to idle at 200, maybe even up towards boiling point, 212 and beyond. So that's not totally abnormal. Nothing should totally mess up unless you're just running straight water, which, I usually don't recommend doing that either. But you'll probably be okay. But when you start to lean into it and you're putting some load on the motor, that is starting to get a little bit warm and you might want to pull some timing. And of course, if you're getting all the way up into 230, 240, your car's starting to actually run really hot. That shouldn't happen. If your cooling system's working well, and everything's functioning, their fans are turning on, you've got the right thermostat and everything else, no air bubbles in the system, you should never be up at 230 with one of these cars. I mean, if you're like a road race kind of guy and you're doing road courses and you're really beating on it, that's maybe an exception to that where you are pushing the extremes, but that's very few of us, and I don't want to talk about that. This is for just kind of the common street strip combos is really what I focus on here. So yeah, so when your coolant temp starts to go up and you're putting a little load on it, you're pulling some timing here. Now, you'll also see that when the engine's cold and you put a little load on it, it's actually adding timing. Now, I have mixed feelings about this. I mean, yes, technically when the engine's cooler, yeah, you can run a little bit more timing and that goes away pretty quick, but I don't know. A lot of times in my tunes, I'm going to go ahead and zero out these guys. So it's not adding timing, but I'll leave all the stuff up top that's pulling timing when it starts to overheat. And if I really want a little bit of extra timing, at idle and some other things, maybe we can do that. But it's just probably safer this way. And you also, you can always run the risk of sensors malfunctioning. I mean, stuff does happen. So if for some reason the coolant temp's reading lower than it actually is, you could end up adding timing when you really don't want to. And I don't like the concept of adding additional timing more than what you normally ask for. Will it be optimal? Maybe you could squeeze a few more out, but in those lower temperatures, but you're probably fine just zeroing this part out, but leave the timing pull up here. So that's pretty straightforward stuff. When you go to the subtractor, there's some other stuff in here, but this is stuff that we don't really have to worry about. This has more to do with idle. And you notice there's also some stuff in here for EGR and MFA. MFA, that's going to be a different topic. We'll get into that another day. But EGR, most of you guys these days have pulled all your emission stuff, including the EGR off the car, cleans up the engine bay, simplifies things a little bit. Very few cars left, Foxbodies that still have this stuff. Now, some of you are in the emissions states where you have to go deal with all that stuff, California and a few others. So, I shouldn't say nobody has this anymore, but a lot of guys don't. If you're one of the people that has taken out the EGR, the other thing you'll want to do in your tune, and this isn't just a boosted thing, this is any of them, you want to turn all that stuff off. And so you can sort of globally disable everything related to EGR by going up into this air section, go to air EGR, and you could tell it what type of EGR system do you have. And you can actually just say, I don't have one. I've taken that out. You disable it. All of those other EGR columns just disappeared. All those other settings go away, and it's not really relevant here. So those adders and subtractors and all these other things, we really don't need to worry about at that point, because again, we're not running that. So all the EGR stuff goes away. So that's really the basics of setting up your timing. Kind of a recap. We disabled the wide open throttle table because it doesn't give us hardly any control, and it doesn't respond well to changes in load, especially on a turbo car. Real big no-no there. So we get that out of the way. The altitude table, if we don't anticipate changes in altitude, we really don't need to bounce between two tables, sea level and altitude. We can run it off one, keep things simple. So we can do it off just the sea level. And then that transition from base to sea level, we've basically killed by changing this lugging table, setting these to all zeros, and making it so they're always above the threshold in which we transition from base to sea level. Therefore, we are always at sea level when the car is moving, and the base table is not needed, so we zero it out. So that's the basics of how the Foxbody's handling the timing. Again, we'll get more into the idle stuff in another day, but for anything when you're driving and using the car, that's kind of how it works. So we'll stop this one here. In the next video, we're going to talk about these guys right here. How do we scale those RPMs and lows so we can have better tuning control at high loads when we're in boost, and higher RPMs depending on how far you want to wind it out. We're going to talk about then, okay, what are some decent starting point values then to use in that sea level table for a common combo like what we're putting together? And then what are all the other changes that, because we've changed the scale for RPM and load, what else do we have to get into here to keep the other parts of the tune happy? So appreciate watching the video. This is part 2, and be looking for part 3 in the next day or two. Thanks, guys.